The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
I want to say thanks so much for having me. It's a super pleasure to be here, and my talk is a little bit different. Definitely deals with online or technology used for teaching. But we're really looking at effectiveness of elementary engineering outreach with personal instruction and videos, both. Now, I'm the only engineer listed on here. I'm the only engineer that was actually involved with this, and everyone else on here is a social scientist. And it was a great experience to work with these social scientists to really step out and do things a little differently, because we're not all the same breeds. And anyway, I learned a whole bunch from them. We've got 3 folks from OSU, Julie Thomas from UMB. It's a very, very awesome group of people that have been focused on STEM education for a long time. So this is definitely a team effort. So I want to acknowledge up front National Science Foundation. I started this work off my NSF Career Award, and then we also got an OSU Provost grant to do this even more. So in summary, this is some of the stuff that I'm going to talk about. But I just tell you up front, I love kids, first of all. I have 2 kids, okay? And I love kids, and I love to spark learning. I love to just see that in their eyes. It's a lot of fun for me. And although we try and have tried for a long time to teach young people and get young people excited about math and science, I think we still got a ways to go. I think we're still going to have some big problems coming up. And I'm going to talk about outreach for 5th graders. And I'm going to talk about then working with pre-service teachers, or teachers that aren't teachers yet. They're still in college. Okay? And so I'm going to first start out with a grand challenge. There's lots of people here at ACI that are giving very important talks about very important things that face our industry. Some of these are immediate, some of these are long-term. But we have a real challenge that's facing our industry. It's really going to sneak up on us if we're not preemptive about it. Our future engineers must provide sustainable, durable, and rapidly constructed infrastructure at similar or lower costs. They're going to be expected to do that. They're also going to be expected to maintain existing infrastructure for as long as possible. Okay? Everyone hears these numbers. ASCE says $2.2 trillion are actually needed to restore our U.S. Infrastructure. And actually, the National Academy of Engineering has finally recognized. We've finally made the list. Civil engineering, we've been trying for so long to come up with important things to work on. We've finally neglected ourselves enough, neglected our transportation enough, that we've made the list, that we are a grand challenge. How are we going to renew this infrastructure? Sad news is that less and less students are choosing engineering every year. And Luke and Billy Snell, some of our own actually, have said that 1% of the 6th graders that they actually talked to wanted to be engineers. 22% want to be doctors. And they said, why is that? Well, they go to the doctor. They see doctors. They know doctors. Doctors are on television, right? They've got a little bit more familiarity with doctors and not as much with engineers. And many sources, and this is one source, lots and lots of sources report that by the 6th grade, students have already decided whether they're interested in studying advanced math and advanced science. If you don't get these kids while they're young, if you don't get them excited while they're young, it's too late. It's too late. At Oklahoma State, and I'm sure other people have certain numbers, but if a student doesn't come in, at least in calculus, there's less than a 1% chance they will graduate with an engineering degree. They're not coming in calculus ready. It's very, very challenging to make it through. U.S. education system, thank goodness, has observed this, have seen this, and they're trying to adjust. They have this thing called the Next Generation Science Centers. Anybody heard about that? Anybody? We got some folks here. Good, got a few. That's pretty cool. They're planning on including engineering at every single grade level. Doesn't it sound typical of the government? I mean, you don't do what you're supposed to be doing for a long time, right? And you realize it's critical. So how are we going to handle it? Well, let's just make kindergartens start learning about engineering. You know, that sounds good. But I'm afraid if you just do it piece by piece by piece at a time, maybe you'll introduce things some maybe a bit too early, maybe you'll introduce things too late. It needs to be a continuous story. It needs to be something that they can see once they have the science and math that they need. Why is this important, and what can they do? So I think this is a good idea, but I think we need concentrated efforts, not piecemeal, okay? Concentrated efforts. Current teachers, sadly, and I guess I can understand this, are not comfortable at all with teaching engineering. I know a lot of teachers, they don't know what they are. I see them, I talk to them. They don't know what engineering is. Okay? A lot of people don't, right? Oh, I don't know about that. Hopefully, by the time you get an engineering degree, you know what engineers do, right? Many superintendents have suggested, and I have quotes from papers, these are awesome, that actually said they're going to just relabel science as engineering. That's how they're going to handle it. Oh my gosh, that's not what we're about here. That's not fixing the problem. Okay? So this is definitely a challenge. This is definitely a challenge. So we need to find a way to introduce engineering concepts to elementary students in engaging ways, exciting ways, get them fired up about it. We also need to help their teachers to become much more comfortable in teaching and covering these topics. Got to cover both these. So what can we do? Well, right now at ACI, a lot of people, really, really smart people, are talking about how to solve problems in our industry. We need to talk about this one. We need to talk about how can we be involved, how can we get involved to try to solve this problem. Okay? And one way to do it is outreach. Really, as an engineer, it's essential for future generations for us to reach out, inspire, educate, let other people know about what a great profession engineering is. Maybe they don't become engineers, but at least they know about it. At least they're more educated. At least they have some idea. When they go to make decisions as voters, they realize, oh yeah, that's important. They might need some money for that. They might need that. It's also extremely rewarding. Outreach is extremely rewarding. You should try it. It's really fun. It promotes your organization as well, promotes your business, your school, and it's also required on many grants. And that's, maybe there's a couple people in the audience because they want to find some outreach activities that they would like to do. So it's a good thing. It's all these things are good things. So I was trying to figure this out. I was figuring out, how can I help? How can I do? What can I do? And you know, I'm a professor, right? And we're supposed to think about these things in big scales. We're supposed to think about research. So I thought, let's think about a research question on this. How can I best use my time to positively impact the attitude and knowledge of engineering for 5th grade students? Why did I pick 5th grade? Well, it was lower than 6th grade, right? And they said that 6th grade was the point where they made the decision. Is it 5th? Is it 4th? Is it 3rd? Yes. Those are all good times. Those are all very good times. But I chose 5th grade because I happened to have a 5th grader at the time. I know what he was covering. I knew what he was doing. I had a feel for where he was at. And I wanted to run a cost-benefit analysis. I wanted to compare the impact I was able to make on 5th graders versus the amount of time that I had to invest. Okay? Because if I can optimize this, if I can get a lot of impact for a little bit amount of my time, that would be awesome. That would be really, really awesome. So to do this, we had to develop age-appropriate and engaging lessons. That was number one. Number two, we had to quantify the knowledge and understanding of engineering concepts before and after my lessons, using pre and post tests. And then we had to use 3 different delivery models that use technology to develop and to deliver the same content with different amounts of time. Okay? So we've got to make the curriculum. We're going to have to quantify before and after. And then the third one's really important. The same message is delivered to 3 different groups with 3 different methods. And they will each use different amounts of my time. Does that make sense? It's really important to get that point, okay? Because I don't want to lose you right there. So we created, and I'm going to talk about each one of these. Let's talk about curriculum first. We created 3 different modules that are 25 minutes each. 25 minutes is a bit long for 5th graders, but we only had 2 objectives, 2 things every day that they had to learn, that it was all about. And every single lesson was a hands-on activity, then a lesson, then another hands-on activity after that. So they weren't spending 25 minutes sitting down listening to me, because who wants to do that? Only you guys. You're going to be here for 40 anyway, right? And then they left, right? Some people just left. Anyway, so hands-on lesson, hands-on right after that. And everything I'm going to talk about is on this website, my website, engineeringiseverywhere.com. That's the name of the actual program. You can go there. We have videos. We have lesson plans. We have all this stuff, okay? And I'll talk more about this stuff in detail, but I just wanted to say it up front. Okay, so in lesson number 1, so they don't know anything about engineering, right? They don't know anything at all. So our hands-on, I give them all ballpoint pens. Okay, give them ballpoint pens. Tell them, take them apart. Put them back together. I want you to write down what each piece does. I want you to tell me, is there another way to do this? It gets them involved, gets their minds moving, gets them doing different things. And then I jump in and I talk about what types of engineers are there. Talk about what subjects do engineers use. And then talk about hands-on number 2. We do an engineering scavenger hunt after that. But what engineers are there? I go through the big ones, not all of them, because there's literally millions of engineers, right? At least in their minds they're all, right? But there's there's civil, electrical, mechanical, industrial, chemical. Someone's offended now because I didn't talk about your engineering type, but that's okay. But I cover the big ones, and I say engineers. What do they use? If you want to be an engineer, you need to use math. You need to use science. You need to use economics. They're like, what? What's that? Never heard of that before. And that's true. They all say that. I never heard of it. And I just say it's money. It's more than that, right? But it's money. And I say, like, those pens you just played with, what are they made of? They're like, oh, plastic. Why? Because it doesn't cost much money. I go, what if you had a solid gold pen? They're like, ooh. They all think it's really cool. Right? And I go, well, we couldn't have near as many of those pens, right, if they were solid gold. Like, what if you lost one? You'd be like, oh, no, my pen. Lost my pen. So we talked about that, okay? So that's the subject, engineering issues. And then we go on this scavenger hunt. So after we talked about what types of engineers are, what they do, we have them go all through the school and try to find different examples of what a mechanical did, what an electrical did. We go outside, what a chemical did, what a civil did. All kinds of things like that. Okay, let's look at some pictures. People like pictures. For example, when I talk about materials engineers, I show stuff like this. I talk about plastic bottles. I talk about ceramics and the greatest material known to man, concrete, right? Right? They all know the difference between cement and concrete. That is a requirement. Okay? And then we always talk about, pure metals, again, the gold. The 5th graders love gold. Okay, you can that's a takeaway from this talk. All right, and this gives them not a lot of words. You can talk about each one of these, and you can talk about the idea, what materials do and what they're all about, and what they focus on. Let's go to those pens. This is what a typical pen looks like taken apart. And I always say, how many pieces are there? And they never take it apart enough. Okay, there's always some little crevice you could break or get apart or get something else out of it. But this is totally broken apart, all the possible pieces. We talk about what they do and all stuff like that. And I say, hey, it's about the ink cartridge. The ink cartridge. How does that work? What is that all about? Okay, and they're like, I don't know, it writes. And they'll even know that it's called a ballpoint pen. But they don't really know how it works. So, well, if you zoom in and you look at that pen, at the very, very, very tip down there, there's a blue area. But there's not blue everywhere. I go, what's the blue? It's the ink. Yeah, okay, they get that. I go, why doesn't the ink just pour out of the pen? Why does it only pour out when you write? And why is it sometimes you write with a pen and nothing comes out, and then a whole lot comes out? Why does that work? So this gets them thinking and going through all these things like that. And we talked about, well, the reasons why it's called a ballpoint pen, and we talked about the history, military actually needed to keep aviation records in the air, and if they used the old ink and quill pens, and they all think that's really cool. And I'll talk about those, drawn with like feathers and stuff like that. I go, if you did that on an airplane and you went upside down, what would happen? And they think that's cool too. And the ink would go everywhere. And I was like, that's really scary, right? So they had to invent the ballpoint pen. Okay? And this idea with the ballpoint pen, again, was a single ball at the end. You have this ink cartridge, right? And when you push it down on the surface, you actually move the ball up, and the ink rolls around the outside of the ball. That's why that ball is blue. And as you roll it across the surface, as you push it across the surface, you leave the ink on the surface behind it. They're like, oh, okay, cool, yeah, that's neat. And I think that's, wow. I was like, that's engineering. That's engineering. Using simple things together in unique systems to accomplish useful goals. That's engineering. That's exciting. And we talk about, hey, chemical engineers help make the ink, right? Materials engineers may make the plastics, right? Mechanical engineers may design some kind of mechanical system. I'm not sure. Actually, I think the designer of the ballpoint pen was a mechanical engineer. So we talk about all of that, and they all think that's really cool. And the coolest thing of all is when they come up with their own examples, okay? I had this girl once. She raised her hand. She says, it's just like a hamster feeder. I'm like, excuse me? These are rural kids in Oklahoma, right? So they have lots of animals, right? I mean, anyways, they're like just like a hamster feeder. And they're like in my hamster's cage. They actually have this little ball on the end with the water, and the hamster comes down and goes, right? And they touch it with their tongue, and then the water comes out and they can drink. And I said, that is exactly right. And all the kids are like, wow, they got it. Hamster feeder. They got it. And that's what you're shooting for. That aha moment. That associating that with engineering, associating that with math and science and making people's lives better. That's what you want to impress on these people, that they can do that. They can feed their hamsters water, right? Lesson number 2. We talked about, first we have them come in there, we have them build block towers. And these are some blocks. And everything, all these things I used are all on the website. I can tell you everything, every place that if you want to get this stuff. They start building these blocks up. These are really, really small wooden blocks. Build them up. And no matter what, and this is a challenge for you engineers out there, no matter what, with these little blocks, you can only stack them 25 blocks high. 25 to 26 blocks high. And they fall over. No matter what. You say, what? How can that be? That blew my mind at first too, right? And we say, so we have them do that. And I say, how high can you get your blocks? How high? Oh, 25. We have a contest. Everyone goes around, see what they can do. And then we talk about what structural engineers do. Right? We give that whole, talk about what structural engineers, and the other objective is, how do engineers use math? Or how do structural engineers use math? Because the secret to the blocks is that they're not perfectly flat. I mean, somebody makes them, right? I mean, they just cut, make millions of these little blocks, right? They're not flat. There's a slope to them. And they don't know what slope is, but they know what hills are. They know what valleys are, and they know what fractions are. And this idea that I can take math and quantify a hill, quantify a valley, is like a totally new concept to them. And that's what we're missing in the elementary school. This idea that math is not just memorizing plus and minus and multiplication and division, but that it has a use. Okay? So then I talk about what we do this. We build with blocks all the time. We build brick buildings, right? And those bricks aren't perfectly flat, because if they were, it'd be too expensive. Economics. We talk about that again too. And so we talk about we use mortar. We use mortar between the bricks, right, to make them fit up and hold them together. So we do the same thing. We give them clay, and they get to build the towers again. And once they do that, they can build them 60 and 70 blocks high. I mean, it's really cool. And that experience of failure, learning a goal or a tool to attack that, a strategy, and then going back and having success is great learning experience for these kids. It's an awesome learning experience for them. Lesson number 3. We have this digital microscopes. Okay, I don't know if that has been an expensive item for this box, is a digital microscope. It's really cool. It's a USB-based microscope, hooks up to the actual laptop, and it's all hands-on. There's 2 buttons. This is great for kids, right? Only 2 buttons, right? They would love it if there was more. They could push them and stuff like that, right? But 2 buttons, so they're really simple to focus and take a picture. And you have a software package that just lets you view them, okay, and stuff like that. So we have all these digital microscopes come, and they come in there, and they can play with them and see how these things work and look at these different materials. And we talk about what's a materials engineer. We talk about how materials engineers really have to understand things on a microscopic scale. The microstructure is extremely important. If I can understand that microstructure, then I can predict much larger performances based off that. We talk about that with wood, how wood and trees are basically just a bunch of straws. Okay, and I have these little straw models. They can try to bend them, and they're weak in this direction and strong in this direction, and that's really good for them. And then we have this microscope scavenger hunt. We have them look all over. Again, this idea that they're going to hands-on, they're going to get up, they're going to be able to do something, and they're going to be able to make observations about different materials, and then make hypotheses on this may be why it performs like this, or if it broke like this. Okay, information like that. Again, that's tying in the how do engineers use science, trying to use science in this thing. So those are the lessons. So how do we quantify change? Well, I talked about we have social scientists involved. So I'm not an expert in this, okay, but I'll do my best. I've learned a lot. Okay, I've learned a whole lot. We have these big ideas, this pre and post questionnaires, and I'm actually finding that the new rage in the world of social science is the post test. So you give them a pre-test, and you give them a post-test, and they better do well on the post-test, right? Because that's what you're setting them up for, right? And then you don't tell them about it, but then like 2 months later, you give them a pop quiz, right? Over the post-test again, and see what they really learned, right? But we didn't do that on this, but that's coming. But we have we have questionnaires like what's an engineer, and these are all research-based quantitative documents. Okay, so this is not something that we came up with. These are things that have been researched by lots of people about what is an engineer and what is technology. It's not just one question, it's a whole page of questions. And then what are their attitudes towards engineering? And we do this thing called Draw an Engineer at Work. And this is something that we did come up with. And this is pretty simple. It looks something like this. It's a single piece of paper, 11 by 17, and it's folded in thirds. So they can only see this first third. That's it. The instructions say, draw an engineer at work. And this is very common. This is the pretest. That's as important before the lessons. They come in, they draw a car, and they don't know anything. They haven't had any lessons. They don't know anything. They draw mechanics, right? They draw mechanics for airplanes, mechanics for cars, things like that. Then you ask, is the person male or female? How are they using math? And they're saying, pretty simple, they're using them to count something. Okay? Is the engineer use science? And they say they don't know. And a sentence about what they're doing. They're supposed to draw bubbles. So, hey, I'm a car engineer and I fix cars. And then you have them unfold it and draw another one. And unfold it again and draw a third. And the idea is that you're pushing the limits of their knowledge. Okay? You're seeing, I've already used that idea. You can't reuse it. You have to use another one. What do they really know? Okay, and you can see the mechanic for a car, mechanic for an airplane, and then my favorite of all, the train engineer, right? Right? Okay, great. And they don't have very in-depth answers. Okay, so that's the pre-test. And then the post-test is kind of exciting. This is the same person on the post-test. And they say, hey, I'm a civil engineer, and I'm working on a bridge. She's got to measure pieces. She's got to use math to measure pieces. She must know what materials to use. Okay, she makes bridge designs. Here's one, industrial engineer, amusement park. Okay? Chemical engineer. The kids love it, man. Chemical engineers, we talk about oil and gas because oil and gas is huge in Oklahoma. But they think it's cool that chemical engineers make food. They just think that's amazing. Okay? And so they all talk about it. And they all say, why don't we have a chemical engineer in our cafeteria? And I said, no. It's not that way. Chemical engineers make food for millions. Right? For millions. So here they are. Hey, she's a chemical engineer. She's an oven. She's making cookies. What a cool job, right? Making cookies for millions. So how do you quantify this? We use a rubric. We look at engineering concepts, use of math, use of science, and all of these different things. We also do something else called a 3-2-1 card. At the end of every lesson, we give every kid an index card. We have them right on the front. 3 things they learned, 2 things they want to know more about, and 1 question they have next time. And I always spend some time answering their questions. And this lets you see, are you getting through to them? Are they learning anything? What's going on? You can kind of adjust mid-stride. You can tailor your lessons to how your teachers or how your students are actually doing. Now let's talk about these delivery models. These are the ones, remember, I'm going to give the same content 3 different times with 3 different efforts, 3 different investment of my time. We're going to have one set of students where I teach every class. That's the most, right? Then we're going to have one where I teach the first class. And then the second are virtual. They're videos of me giving the same lessons that I taped at Oklahoma State that are available for free on that website. Okay. And then we have the third, all virtual. They never meet me. They never talk to me. All virtual, 100%. There is a one-day workshop that we hold with the teachers to get them comfortable with engineering, get them comfortable with answering the students' questions, get them some idea so they truly know the content. Okay? That's important. The results. Now, nobody wants to look at things like this, but we have things like our ends, we have our pre-test means, our post-test means, and our p-values, or how significant is our results. And the lower the p-value, the more the significant the changes. What I'm going to do is color code this. So if something is white, it means there wasn't significant change. Something is tan, we go to a darker orange, hook 'em, right, burnt orange. Right? And we got the OSU in the middle, maybe. There it is. That's how it actually falls out. And you can see that what you want is tan, or I'm sorry, dark, the darkest one, and what you don't want is light. And we can see, look at this. Here's the virtual one. Dark, 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 and then a little bit lighter. Dark, 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 dark. Hey, these are about the same, even though there's some differences in certain subjects. On average, they're about the same. And let's look at the expert-led. None of them were dark. This just confirms something my wife has said forever, right? Nobody likes to hear me talk, right? Or they like to be able to turn me off whenever they want to, right? Or pause me. This is interesting. I wasn't more effective than the videos. It's like I lost to technology. But maybe that's a good thing. Maybe this is a battle worth losing. Because if it's the same content, and they're going to get more from the videos, and it's going to require less of my time, I won. Didn't I? I won. This is cool. For these students in measurement techniques, the expert-led students did not show increased change when compared to the other delivery methods. And there was little difference between whether I visited once or never. This suggests the subject experts should spend their time developing curriculum and training teachers on how to present it. That's what this suggests for 5th graders. Okay? So what's the best way to train a teacher, though? That's kind of like part number 2. If we train the students, I mean, we've got to get these teachers. We've got to get them involved. Well, we actually repeated all these experiments, not all of them, but most of them, with senior education majors at Oklahoma State. We did this expert visit, then virtual lessons. Actually, I visited and taught the first lesson, and then we had the videos just after that. We had an expert teacher, too, an education teacher that actually counseled them and talked to them about these different things. And then we had the third one where I never visited. We had all virtual lessons. We're going to do the same thing we showed before, and we didn't get the same results. The college students liked meeting me. Wow, it's good to know that you're appreciated, right? The college students benefit from more of my time than the 5th graders did. It's peculiar. That's what it is. That's what it shows. Again, the virtual's got all this white. White's bad. White means there wasn't significant change. Okay? This means we saw significant changes, but the good news is they all feel ready to teach engineering. They feel better prepared to teach engineering. So that's good. They don't necessarily know what it means. They don't really know what technology is. They couldn't draw one to save themselves. But dang it, they are ready to teach it. Right? That's what the data suggests. This paper is going to be fun to write, right? So the 5th grade, the teacher results does not match the 5th grade student data. The expert visit was much more effective than the virtual lessons, and neither group showed an understanding of how engineers use math and science, and that's bad. That's a fundamental flaw. That has to get fixed. Okay? So what's that suggest? We've got to do something different. Right? We've got to do something different. So perhaps we need a different approach to train teachers. Perhaps we need different curriculum. Perhaps we need, because this was developed for fifth graders, right? And they were trying to tell them how to apply it and how to use it. But perhaps we need to take a different approach to this. Perhaps we need increased expert time with the teachers, or I think this is a good idea. We can use assignments where we force them to prepare curriculum. You know, you always hear the old adage, you learn best by doing. If you make them prepare curriculum, if you make them teach it, and then you critique them or ask them questions afterwards, I think that's a good way to help these teachers learn how to teach engineering. Let's talk about the future. We've already able to reach 280 students per year with no money. It's in the school. There's no more money required. This is now, the teachers are so excited about this. This has become part of their curriculum. This is what they're going to use every year. Okay? And they're going to do it at the beginning of the year. And they're going to use engineering in writing. They're going to use engineering in math throughout the year. It's kind of cool. It's kind of cool how they're doing it. And we'll keep reaching this many per year with no extra costs. It costs us roughly $350 to put one of these boxes together, all these hands-on activities. Okay? The videos are made, no more cost needed in that. To put all the microscopes together, all the little blocks, all that stuff like that. $350. And this is per school, that's about 70 kids. So everyone in that school would have access to that box and get that training. And this one-time cost will cover that school for roughly 5 years, maybe more. If you get, that's 350 kids. That's $1 per kid to give them this opportunity to learn about engineering. I know everyone in this room at some point, I mean, unless you were just had a parent that was an engineer, at some point you had somebody that sparked that for you, that got you excited about engineering and what it was. Thank you, sir. $1 per child per year. That's great. That's a great opportunity to be able to give that to somebody else. So how can you help? Well, if you know a company, an individual, or a grant that would be interested in helping sponsor something like this, sponsor a school, you would be happy to put your sticker on the side of the box or whatever. I know this box is brought to you by whomever. We need help. Okay? Please let us know about it. The teacher's going to need a one-day training. So if you have ideas, Pennsylvania or something like that, you have some folks, you're going to have to do the training there, right? If they're in Oklahoma, we're going to be doing the training every year, okay? So the teacher is going to need some kind of training. But please do your part to help out, whether it's with this, whether it's your own ideas, okay? We need to do something. This is a big problem that's coming, okay? We've got to start handling it now. We need creative engineers. We need more of them. We need people that are going to solve these future problems. And I know we are all busy, but these efforts can make a big difference in people's lives. So in conclusion, developing our future engineers is really important. The outreach curriculum presented was shown to make a positive impact on fifth graders about engineering concepts and the profession. Impact was observed for all of the curriculum delivery models. There was no measurable difference for the impact on fifth graders despite the difference in time commitment by the subject matter expert. I'm just going to reiterate that again. It didn't matter whether I taught all 3 lessons or they only saw me virtually. There was impact both ways. There was no measurable difference. And it's recommended to use subject matter expert time to develop content and train teachers on how to deliver it. The education majors did not have the same response as the fifth graders. We've got to do more work on that. We've got to figure that out. But that's okay. Quantitative comparison methods are useful to determine the effectiveness of your outreach efforts, and I suggest everyone in here, if you're going to do some outreach, it doesn't take that much more work to do in pre and post. I will send you everything you need. Okay? It's not that hard. Okay? There's my website again, engineeringiseverywhere.com. Please visit it if you can. Okay? And I also want to have any questions, and I want to leave this with a final plug from another website of mine called Hydration Theater. Okay, and Hydration Theater is a play that I've written with my students where they actually become the molecules. Okay, they actually act out the steps of hydration. Okay, and we do this every year, and there's going to be a new one coming up. And actually have a Hydration Theater attendee and an audience attendee right there in the back at tonight. Yeah, thank you, Brett. There's my website at tylerlay.com if you have any questions. Thank you so much for your time.